Foundational to the study of geometry is the Pythagorean Theorem and the distance formula, where the distance formula is really just a version of the Pythagorean Theorem. The Pythagorean Theorem relates to right triangles. If you have a right triangle, it states that a squared plus b squared is equal to c squared, where a is the length of one of the sides, b is the length of another one of the sides, and c is the length of the hypotenuse. So knowing that, let's do a problem. The length of the hypotenuse in the figure above is closest to what integer? Alright, so we have grid paper in the background, so we can estimate the length of A and the length of B. So A looks to be approximately 1, 2, 3, 4 units, and B looks to be approximately 1, 2, 3 units. So we can do 4 squared plus 3 squared equals c squared. That simplifies to 16 plus 9 is equal to c squared, or 25 is equal to c squared. And we can take the square root of both sides, so we'll get c is equal to 5. So the hypotenuse is 5 units. Given a right triangle with a hypotenuse of length 5, a side of length a, and another side of length 2a, find the value of a. Let's put this in terms of the Pythagorean theorem. So we have one side a, so we're going to do a squared, plus another side 2a, so we're going to do 2a squared, and we have the hypotenuse length 5, so we're going to set that equal to 5 squared. Alright, so that's going to give us a squared plus 4a squared equals 25. So we can make that 5a squared equals 25. Let's divide both sides by 5, and that'll give us a squared is equal to 5, and then we'll take the square root of both sides, and that'll give us a is equal to the square root of 5. Let's move on now to the distance formula, which states that the distance d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. You may notice that I can substitute for d if I wrote c, and if I substituted for x2 minus x1 a, and I substituted for y2 minus y1 b, then I would really just have the Pythagorean theorem. This makes sense if we look at the figure above. We have a point A at coordinate 3, 2, and a point B at coordinates -3 and -1. So all we're really doing is we're finding the difference of the x-coordinates, so we're going from -3 to +3. And then we're finding the difference of the y-coordinates, so we're going from 2 to -1. And if you see here, now we just have a right triangle. And we know that the distance between the x-coordinates is 1, 2, 3, 4, 5, 6 units, and the distance between the y-coordinates is 1, 2, 3. So using the Pythagorean theorem, we can figure out the distance between a and b. So let's do this. Let's actually calculate it. So what is the distance between points A and B in the graph above? So let's actually write this out using the distance formula, even though we can take the shortcut of just counting. But we have d equals the square root of, so we have x2 minus x1, so that's -3 minus 3 squared, plus y2 minus y1, so -1 minus 2 squared. When we simplify this a little bit, we get d is equal to the square root of -6 squared plus -3 squared, which of course equals 36 plus 9, and then you take the square root of that. So the distance is really just equal to the square root of 45. which is fine for an answer, or you can simplify that a little bit further if you don't like the radical written like that. But for this, we'll just leave it as root 45. Let's do another problem. The distance between 2 points A and B is 10 units. Point A is located at coordinates 0, 0. Point B is located at coordinates 6, y. What is the absolute value of y? Alright, so this problem looks pretty complicated at first glance, but really it's fairly simple. It's simple because we're starting at point 0, 0. So if we have a graph here, I'll just draw one really quick. And we have a point at 0, 0. And then we know that we're at point 6, y. So we're not sure if we're going in the positive direction or the negative direction, but it doesn't really matter because we're just going to square it anyway. And we're just asked what the absolute value of y is, so it really doesn't matter. So we're 6 units this direction. Now we need to know how many units in the y direction we go, because we know that this distance is 10. So now we have a right triangle, we know the hypotenuse, and we know the distance between the x coordinates is 6. So we can rewrite this as 10 squared is equal to 6 squared plus y squared, or 100 minus 36 is equal to y squared. So we get 64 is equal to y squared, so we know that y is equal to 8. It also could be negative 8, but it's asking for the absolute value, so we're going to get the value is 8.